Hello, in this video I will show you how you can import already existing data to the field map project from inventory project. So again we will need the field map software and also the field map project and data. So I have here data from NOAA, so I have the grid of points. It's a shapefile. If I open it, you can see that there are those points and each point have a plot ID. I think this is the most important, is plot ID, and of course in the shapefile are coordinates in VGS in UTM-84 system. So then we have polygons of the Rhodales, so different polygons. Unfortunately here is ID 0 for each polygon, so you can see that here ID is 0, so we cannot use it as a ID of Rhodales, but we have the Rhodales ID in string attribute num Rhodal, so we can manually use it. And then we have Excel with data. In Excel are several sheets. The first one, I hope it contains data from all Rhodales, because there is also ID of Rhodal. So, and then of course we will need a field map project. Again we can start from the empty project. I call this project PMF Sitios de Muestreo. So the folder of the project you can call whatever you want. So if I open it in data collector, so you can see that there is only one parcella is volume equation. So there are parameters for volume calculation. So we will start with the inventory area plot. So go to new parcella, new plot, and the ID of this plot we can use 0, because it cannot be the same ID as the ID of inventory plots, and we can call it for example inventory area plot or whatever. So then we have to import the shapefile with the border of our inventory area. We have only this Rhodales, so we can select this polygonal shapefile and select all polygons, and the field map will join all these polygons to one and use it as a plot border area. So using this selection, so only the green polygons are used as a plot border area. So I select all, so all of them are green. So click OK, and then of course it's very important to select coordinate system. In your case it's UTN zone 14 north, so I'll select the UTN zone system, click OK, and then you have import the plot border in the field map project. Then it's very important to select data about the parcella, because we have a predefined type of parcella Sitios de Muestreo. We have to change it to area de inventario. So, and you will see immediately that some new layers are available and the other disappeared. So if we go to map, so you see that we have available Rhodales and Mala de Puntos, so it's a grid. So select the Rhodales and import polygons of Rhodales. Tools, import kappa, Importar polygonos, and we use the same shapefile as a plot border, but in this time we will import it polygon by polygon, not joined together but all the polygons individually. So select production. Don't link ID, because in ID of a polygon you have 0. So if you have ID of Rhodales, that would be great, but you don't have it there, so don't link it, otherwise we will have key violation, we will have duplicity in ID in field map. And we have attribute num Rhodales, but unfortunately it's a string, so we cannot link it with numero de rodales, so it's not possible because in field map project we have it as a number. So select numero rodales and import it to node, because a node is a string. Click OK. So then you have the polygons in field map, and if you select some polygon and go to the attribute page, so you can see that this node was imported, and manually fill data. For example, this one is rodales 19, so numero de rodales will be 19. Then this one is 28, fill 28. This one is 27, 4 is 23, and 5 is 31. So you can fill also other data about the rodales if you have, if you know the treatment, date of measurement, and so on. And there is very important attribute is superficie inventory in hectares. If you want to use the same as the area, but here is in square meters, so you can right mouse click here and select realizar script on change para todos, and select the area script, and then the script will go rodal by rodal and recalculate the area to hectares, from square meters to hectares. So now we have filled the data here. So if I go back to map and go to full zoom, so then we have the rodales, but what we don't have is inventory points, the grid of inventory plots. So for this we have a special layer via the puntos grid. So double click to the layer, and again with the same method select the tools and import points. And the points we have in a shapefile diseño 150, select OK. And now it's very important to link plot ID, because we have to know what ID of the point is corresponded in shapefile and the target field map project. So luckily it's numerical, so we can easily link it and click OK. So now we have a grid of inventory points imported in field map. So for each point we have only information if it was finished or not finished. So this inventory maybe it was finished fully, so we can fill this attribute with this function. We don't need to go plot by plot, but with this function we can fill, for example, is complete, fill like this, and so on. So now we have, you can see that the symbol of finished plots is different. So now we have grid imported already in navigation plot or in this area de inventario, and we have to now create plot by plot the inventory plots. So we can do it by tool import to field map, but unfortunately in this project you have a global coordinate for each tree, so we have to do it different way. So the most easy way is that you close data collector and open the same project in project manager, and then there is a function in tools, it's called create set of plots, crear set de parcelas, and all our plots are circular with same size, with same radius. So here you fill the radius of your plots. So I know that your plots are size 1000 square meters. So I fill here the radius. The radius is 17.94 meters. So when I go back, create set of plots, and I fill here exactly the radius of the 1000 square meters. So this method can be used only if you have all plots with the same size and same shape in your inventory, but this is your case, so we can use it. Click OK. So now we have the new window, and we need to find a table where we have ID of plots and coordinates of plots. So because we use the shapefile of inventory plots and import it to the field map, so this table was automatically created in our project. So we can go to our project we already opened, and there is directly in this folder is Firebird database, field map data, Sitios de Muestreo. Click OK, and our layer or our table is called grid. And here we can just link ID and coordinates. So ID is ID, name of plot we don't have here, so we can use again ID. X coordinates is X, Y coordinate, and because we don't have Z information, so just select the none. Click OK, and now field map will show you how many plots will create in field map and what will be their ID and coordinates in UTM zone 14. And so then click create parcellas, and the field map create these plots in data collector or in database, so then you can use it in data collector. So you can see that from the area, from the radius, it was recalculate the area, and it's exactly 1000 square meters. So then I can close it, close project manager, and open again the same project in data collector. And so this is our navigation plot, and if I go to open plot, so you can see that they are all the plots also in global coordinates. So I select the first, for example number 6, and now I have to manually fill some data plot by plot. So select the first plot, and then select the region is Hidalgo, region 1303, and tipo de muestreo is Sitio de Muestreo Rodal, so it's an inventory plot. Then go to tools, georeferencing, and convert plot from local to global coordinate system. So the first you have to select UTM zone 14. The GPS coordinate point we already have, because it was automatically created in project manager when we import the table, so you don't need to link data as I show you on the training. So here you have pre-prepared, so this method is much better, much faster. And click local to global. Yes, it's converted to global, so you can see if you are on the plot that here are coordinates in global coordinates. So on this you have to do plot by plot like this. So it takes for this project approximately 10 minutes. So select plot number 7, click OK, and go parcela, fill Hidalgo, region, so this one, and Sitio de Muestreo, back to map, tools, georeferencing, VGS 84 zone 14, local to global, OK, finish. So unfortunately there is no faster way, but 10 minutes is I believe is no big problem. You can use also hotkeys. If you click F4, it opens the plot, and if you click F9, it will open the georeferencing. Georeferencing is F9. So now we have all plots ready, so we convert all inventory plots to global coordinate system. So don't forget to make a backup time to time, because if you make a mistake, so you can easily delete the project and go back to make to some backup. So here in tools you can use the function create backup, and you also use some keyword, for example after conversion to global. So then I will know that this zip archive will have name in the end after the conversion to global coordinate system, and then you can see unpack. So here is the folder backup. It's in the same folder where is the film project, and inside is zip. So and you can see there here is the keyword I use in the name of the zip archive. In the zip archive is complete film project. So if something happen, I can delete this project and go back to the backup and unpack it and continue the work. So that's why it's very important to create backups. Okay, so now we have the backup, and we can import data. So for the import, of course you can do it plot by plot, but it will be a lot of work. So more easy way is to use tool import to field map. For the import to field map, we will need three objects or three things. First, we need a field map project, then we need a XML profile, and then source data from which we take the data. So our source data is here Sitios de Muestreo Excel. In the Excel we have coordinates of each tree. There is a ID of Redales, ID of plot, so it's very important, ID Sitio, ID arbol, XY coordinates, and species, diameter, altura, edat, and so on. So then we can prepare the Excel XML. So for example, you can open it. I already have some example prepared, but in Notepad you can prepare it easily. Use the help for import to field map. So there is describe everything, and in this Excel it's just XML. Sorry, it's just written word with the source table. So the name we will import to the layer 3. Source table or source data are in table, and the file name is Sitios de Muestreo. So it's exactly the name of the Excel, Sitios de Muestreo. Then name of the sheet. So in this case is OEA 1, and in Excel you have to use this sign in the end. So the dollar. Don't ask me why, I don't know. So then we have to fill what is a plot ID. In Excel is ID Sitio. What is the ID of tree? In Excel is ID arbol. So here we have to change it. In this example, ID arbol. And what is X and Y coordinates? So X is X, Y is Y coordinates. So and then we can link also attributes. So attribute name species in field map is in a source table called species. Attribute diameter in millimeters we don't have here, so we have only diameter in centimeters. So diameter in centimeter is diameter, and but we can also import here diameter in millimeters, and we can use the parameter multi, and in this case we can multiply by 0.1. So it means that multiply by 10. So it means that data in centimeters, so for example 22, will be multiplied by 10, so it's 220. Also we can link height. Altura is called in the source table, in original is height, age is edat, TP is TP. So like this you prepare your XML, then save it. This table you should close before the import. I did not change it. And also it's good to validate the XML, so open it, for example, in browser, for example Edge, and if the XML is valid, so then you will see it properly in the Edge. If there is an error or problem, so you will have empty or some message that the XML is not valid. So each web browser is also XML validator. So and now we have all already, and we can use the tools import to field map. So it's in the same folder as field map, but in subfolder tools. Import to field map, so it's a tool. Double click on it. So in the first step we will open the field map project. So it's our field map project. Then we have to link where is our XML profile. So in this case it's in desktop, Sitios de Muestreo import. Okay, and then click process data and find where is the Excel. So in my case it's again on the desktop, but now I have to find it. It's in C users Peter desktop Sitios de Muestreo. It's exactly here in the Sitios de Muestreo folder. Click OK. And if you set everything properly, then the data start to be imported. Okay, finish. So I can close it. Close this and open the field map project again in data collector. I can select, for example, plot number 8 or whatever. So after the import is finished, we can see the data in data collector. So plot by plot we can see. So you can see that some of the plots are going outside of the plot, so it's probably because of an error of a GPS. So we can calculate the resume for all plots, but before I recommend you to go to settings and deactivate function measure for message if the tree is outside of the plot, because otherwise you will get many messages. You have to confirm that you don't want to delete trees outside of the plot, because all these trees are outside of the plot and they should be deleted. So task and calculate all resume for all plots, and now it will go plot by plot and calculate all the data for each plot. So after this calculation, we should have calculated the volume for all trees, and also there should be some summary per plot. So these data are only for currently selected plot. So in the map you can see that there are symbols, all of them are black, so we can refresh symbols in the settings. There is symbols, the kappa, and actualize the symbols, and for each species there's a different color, so you can of course change the color and so on. So but now it's refreshed, and each color represents different species. So we have prepared that data for plot by plot. So and then we can calculate summary per rodal. But before we will do it, so it's very important to have information in each plot what rodal it belongs to. So for example, this is the rodal 23, and rodal 23 has plot 8, 9, 13, 14, 15. So this information we should add to each of these plots. So select, for example, plot 8, and in the attribute number of the rodal, fill 23. The same for plot number 9, 23, 13, 14, and 15. So like this you should add this data for each inventory plot. So for example, this is the rodal 19, and there are plots 16, 17, 24, 5, 6. Okay, let's finish also this one. 16 is rodal 19, 17 is also 19, and then it was 24, 5, 6, 24, it's 19, 25, it's 19, and 26, it's 19. So like this you will fill it for all plots, of course. So now I think these two are enough, and I go to rodales. So for example, select the rodal 23, and then here is the function to calculate resumen from inventario. Click execute, and it will calculate for all the rodales, and only for 23 and 19 we should have some data. So it's a 19, and this is calculated from all inventory plots, and this is 23. It's 23. So you see that others don't have calculated data because don't have any inventory plot. So if we want, for example, for this 31, we have to fill data 31 for plots 23, 66, 61, 23, and it's 31. So like this you have to fill it for each inventory plot, and then you will also get the results also for 31. Okay, bye.